Okay, so 3.4 is zeros of the polynomials. And so we've talked about the zeros before. Remember, those are our x-intercepts, our solutions, and our roots. Okay? And so what we did before is we used factoring to help us solve them. But what happens when we can't actually factor our polynomial? If we can't factor our polynomial, then we're going to use what they call the rational zero theorem to help us find all the possible rational zeros. Alright, so what that does is it tells us that we're going to take, I'll call it our P's and Q's, because they say that our constant term here, doesn't matter if it's positive or negative, is going to give us all of our P's. So the P's is the factors of that constant term, and our Q's are going to be the factors of the leading coefficient. Alright, so, and then we're going to find the ratio of them, and that'll tell us all the possible rational zeros. Which means if there's a rational zero for that polynomial, it will be in the list that we're given. Alright, so let's start off. So P. P is going to be all the factors of that constant, which is a 3. And so the factors of 3 are positive and negative 1 and positive and negative 3. Remember, it's what multiplies in to give us 3, or what 3 is evenly divisible by. Q is going to be all the factors of the leading coefficient, which is 4. And so positive and negative 1, positive and negative 2, and positive and negative 4. Everything that 4 is evenly divisible by. Then, to actually find your possible rational zeros, you're going to take every P and you're going to divide it by every Q. So you need to find some type of a pattern, okay? So what I'm going to do, let me change colors here, is I'm going to take this P and I'm going to put it over every single Q. And then I'll take the next P and put it over every single Q. And I would keep doing that until I've used all of my P's, and in that case I would have all of my possible rational zeros. Alright, so I'm going to take that 1 right there for that P, and I'm going to put over my first Q, which is 1. So positive and negative 1 divided by positive negative 1, you're automatically going to get plus or minus, okay? 1 divided by 1 is 1. Then I'm going to take that plus or minus 1, that's my P, over my next Q, which is 2. So 1 over 2 would be 1/2. And we're going to put plus or minus in front of it. And then I'm going to go to my next Q. So that first P, that is a 1, and I'm going to divide it by 4. 1 divided by 4 is 1/4. Now, I've used all of the Q's with that P, so now I'm going to switch P's. So now I'm going to go to the plus or minus 3, and I'm going to put it over all of my Q's. So 3 over 1 is 3, so we're going to put plus or minus 3. 3 over 2 is 3/2, so plus or minus 3/2. And 3 over 4 is plus or minus 3/4. Now, since I don't have any more, well, I took that 3 over every Q, and I don't have any more P's, so these are all my possible rational zeros. Which means if I have a zero that is a rational number, it's going to be in that list. Now, how many actual possible rational zeros do we have? Well, here's 2. Here's 2 more, so it's 4, 6, 8, 10. We have 12 possible rational zeros. Remember, each one of them is plus or minus, so it counts as 2 different ones. Positive 1, negative 1, positive 1/2, negative 1/2, and so forth. Alright, so I'm going to do the next one. If you want to pause it and try it first, do so. Okay, so P is going to be the factors of my constant term, which is a 6. And so the factors of 6 are 1, 2, 3, and 6. Q are going to be the factors of my leading coefficient, which is a 3. So plus or minus 1, plus or minus 3. And so my possible rational zeros are going to be all of my P's over all of my Q's. So just like I did earlier, I'm going to take this 1 and I'm going to put it over both of my Q's. So I have 1 over 1, which is 1, and 1 over 3, which is 1/3. Now I'm going to take my next P, which is a 2, over both of my Q's. So 2 over 1 is 2, and 2 over 3 is 2/3. Then I'm going to take my next P, which is a 3, over both of my Q's. So 3 over 1 is 3. And 3 over 3 is 1. But I already have 1 written right here at the very beginning, so I do not have to write it again. Alright, then I'm going to take my last p, which is 6, and I'm going to put it over both of my q's. So 6 over 1 is 6, and 6 over 3 is 2, but I already have 2 written, so I do not have to write it again. So here are all my possible rational zeros. Alright, so the next part says now we're going to find the zeros of the polynomial function. Okay, so what we want to do here now is we're going to find our possible rational zeros, and we're going to use those numbers from that list to find at least one that's going to work. I can do that by plugging it into the function and see if I get 0, because remember that we talked about the remainder theorem in 3.3. So if it equals 0, then we know it's evenly divisible, which means then we can do our synthetic division, or long division if you prefer. Or I'm just going to go ahead and jump in and do synthetic division. If my remainder is not 0, then I try a different one. If my remainder is 0, then I've got my answer and I'm ready to move on. Alright, so let's look at number 2. So the first thing we're going to do on solved problem number 2 is we're going to find our possible rational zeros. Alright, so to do that, we're going to do our p's and q's. So step 1. So p, remember, are the factors of the constant, which in this case is a 2. So factors of 2 are just 1 and 2, plus or minus, of course. And then we're going to find the factors of q, which are the leading coefficient, which are 1, and the factors of 1 is just plus or minus 1. So when we find our p over q's here, it's going to be every p over every q. So we just have the 1 over 1, so plus or minus 1, and then 2 over 1, so plus or minus 2. So we have 4 options there, positive 1, negative 1, positive 2, negative 2. Now, we're just going to pick one of those and try using synthetic division for it. So choose one. I'm going to choose the number 2, positive 2. So I'm going to put a 2 here. Now I'm just doing my synthetic division, so I'm going to take all of my coefficients here. Remember, it's got to be in descending order of the exponents, and every exponent has to be accounted for. So my largest exponent, like on this one, is cubed. I have to have x to the third, x squared, x, and then our constant, which we do have here. So we have a 1x cubed, a 1x squared, a negative 5x, and a negative 2. So now remember, if 2 is a 0 of this polynomial, my remainder will be 0. If not, I need to pick another one. Alright, so bring down the 1 times the 2, combine them, times the 2, combine them, times the 2, combine them, and we got 0. So what that tells us is that we divided by 2, so we know when we put that back in with x, it would be x minus 2, because remember we had to change the sign to take it out, times, and remember our answer starts with 1 less on the exponent than our problem. Our problem started with x cubed, so our answer is going to start with x squared. So we have 1x squared plus 3x plus 1. So f of x is equal to this here. Now, we want to keep factoring if possible, but my trinomial is not factorable. So I'm going to set these equal to 0. And so what we need to do then is we're going to set them each equal to 0. So x minus 2 equals 0. X squared plus 3x plus 1 equals 0. I can solve this first one. And there's that 2 that we used, okay? So we know that 2 is going to be a 0. Now, I can't factor this piece. So how else can we solve it? We can use our quadratic formula. So remember that our a is 1, our b is 3, and our c is 1. So we're going to do x equals negative b plus or minus square root b squared minus 4ac all over 2a. Excuse me. Alright, so make sure you plug your numbers in. So negative b squared 4ac over 2a. And then simplify this. So 9 minus 4, so that's a 5 all over 2. Alright, and let's see, 5 is prime, so we can't simplify our radical. The 3 numbers outside the radical are not divisible by anything other than 1. So here are our other 2 zeros. So, just to kind of put it together here, so our zeros are going to be x equals 2, x equals 3, negative 3 minus the square root of 5 all over 2, and x equals negative 3 plus the square root of 5 all over 2. And so there are the zeros of this problem. Alright, so I'm going to do pencil problem number 2. So again, if you want to pause the video so you can try it on your own, do so. Alright, so let's go find those p's and q's. So p's, remember, are the factors of the constant, which are 6. So plus or minus 1, 2, 3, and 6. Q are the factors of the leading coefficient, which is a 1. So it's just plus or minus 1. And so my possible rational zeros are all of my p's divided by all of my q's. So we get 1, 2, 3, and 6. Alright, then I have to pick one. And so, I don't know, let's try, how many different options do we have? 1, 2, 3, 4 times 2. So we have 8 different options. So let's try positive 1. Let's put a 1 in my box, put out my coefficients, make sure that they're all in descending order of the exponents, and every exponent's accounted for. So 1x cubed, 4x squared, negative 3x, and negative 6 is my constant. Do my synthetic division. Alright, this one did not give me a 0. What that tells me is that 1 is not a 0, or I made a mistake, okay? So I'm going to try another one. So let's try negative 1. Alright, so 1, 4, negative 3, and negative 6 are my coefficients. And that one worked. So we know that we have x minus 1 times x squared plus 3x minus 6 is our polynomial. We're looking for the 0, so we're going to set it equal to 0. Now, can I factor out that trinomial? Is there anything that multiplies a 6 that will subtract a 3? 2 and 3, 1 and 6, there is not. So I'm going to set them each individually equal to 0. I'm going to solve this first one. Uh-oh. Where did I mess up at? Hopefully you caught it. Uh-oh. Don't want to erase all that. When I took this 1 and I plugged it back in parentheses, I didn't change its sign. It should be an x plus 1 inside there. Because when I solve it, I should always get the actual number that we used, okay? So x equals negative 1. Now this one here, again, we cannot factor that, so we're just going to have to use our quadratic formula. So we know our a is 1, our b is a positive 3, and our c is a negative 6. So we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Plug them in. Alright, so when we do this, we get negative 3 plus or minus the square root of, I've got 9 plus 24 is what, 33, all over 2. Alright, again, I can't simplify the 33. It's just 1 and 33, or it's 3 and 11. When I try to simplify it, you can't do anything with that. Can't reduce this. So there's your other 2 zeros. So you got x equals negative 1, x equals negative 3 plus the square root of 33 over 2, and x equals negative 3 minus the square root of 33 all over 2 as your 3 solutions. Alright, now it wants us to solve the polynomial. It's the same thing, guys, okay? You could check to see if possibly if you could factor them. But like on the first number 3 there, you have 5 terms. We haven't talked about how to factor 5 terms. So we can't do that. So we're just going to use our P's and Q's to help us. Alright, so remember P's. Let me turn my pen back on. P's are going to be the factors of the constant. So P here is the factors of the 13, which are just plus or minus 1 and plus or minus 13. Q is going to be the factors of the leading coefficient, which is a 1, which is just plus or minus 1. So our P over Q's is going to be 1 and 13. Alright, so we got to pick one of these and try it. I was trying to see if I could find a way here to do this, but it seems I don't have my paper there. Yeah, I do. I just overlooked it. Sorry. So to keep us from having to just keep doing trial and error, I'll help us out. So let's try 1. Remember, if you pick a number and it doesn't work, just pick a different one, okay? So we have 1x to the 4th, negative 6x cubed, positive 22x squared, negative 30x, and positive 13. Let's do our synthetic division. And so once we do that, we've got the x, remember change the sign when you put it back in, times, our problem started out with x to the 4th, so our answer is going to start out with x cubed. So x cubed minus 5x squared plus 17x minus 13. And this is still equal to 0. Alright, well, let's see. I can't factor this, but it's also not quadratic. So what I'm going to do is I'm going to find me another 0 to try again. Okay, I'm going to pick another one of those possible rational zeros and try it again. It may be the same number we just used, or it could be a different number. So I just have to pick one. So I'm going to go ahead and try the same number again. Alright, so I'm just working on this part right here right now. So we've got, I'm going to put a 1 here again, and I'm going to now use my new coefficients. I'm going to use the 1, the negative 5, the 17, and the negative 13. And we're doing this a second time because now this is going to take that x cubed that we have right here, and it's going to bring it down to x squared, where either we can factor it or we could use our quadratic formula. Alright, so let's go ahead and do our synthetic division. And it worked. So what we have now is we had the original x minus 1 that we came up with. We have our new x minus 1 that we just figured out. And then what we have is our answer. So remember, this problem started out with x cubed, so now we're down to x squared. So minus 4x plus 13 equals 0. Alright, well, I need to see, can I factor this? Nothing multiplies to 13 that I add to 4, but we know, we know that it's quadratic because of the x squared, so therefore we can use our quadratic formula. Alright, so I'm just going to go ahead and solve both of these. So x minus 1 equals 0, x minus 1 equals 0. So we get x equals 1, x equals 1. So remember that means, because it's the same, that there's multiplicity of 2. So if I was going to write out my zeros over here, my zeros, I would have x equals 1, multiplicity of 2, meaning it's there twice, it counts for 2 of them, and then whatever we get from our quadratic formula. Now you have some room probably below this, but because if I scroll down, I lose everything I've got. I'm going to do my quadratic formula over here on the next side. So I know that my A is 1, my B is -4, and my C is 13. So we have x equals -b plus or minus square root b squared minus 4ac all over 2a. Alright, so plug it in. So b is -4 minus 4ac. A is 1, C is 13, all over 2a. So we get 4 plus or minus the square root of, I'm going to have to put this one down, so this is 16 minus 52, all over 2. So x equals 4 plus or minus, it's a -36, I believe. Square root of -36, all over 2. We can take the square root of -36, so we get 4 plus or minus 6i all over 2. Now all three numbers here that are not under the radical are divisible by 2, so we can reduce that. And so we get 2 plus or minus 3i all over 1, but I don't have to put the all over 1. So here is my other two zeros. So we would have x equals 2 plus 3i and x equals 2 minus 3i. Now remember, I believe we had also talked about the largest exponent. The degree tells us how many zeros we should have total. So we should have 4 total. We do because that x equals 1 counts for 2 of them. It had multiplicity of 2. So therefore, we have 4 zeros. Alright, so just like before, I'm going to do the pencil problem. So if you want to pause this so you can try it, do that. I'm going to erase what I have on the other side here, though, so I have room. Alright. Same thing, though, because we're solving it. Remember, we had said that the zeros are the same thing as the roots, the x-intercepts, and the solutions. So if I'm solving, I'm looking for a solution. So I know P is going to be the factors of my constant, which is 12, which are 1, 2, 3, 4, 6, and 12. Alright, and I put them in order so I don't forget, and then I can see 3 times 4, 2 times 6, 1 times 12. The only time they won't pair up like that is if you have one that's a square root, okay? And then I'll have that single one in the middle, the square root of it, and then they pair up. Alright, Q's are going to be the factors of my leading coefficient, which is a 1. So just plus or minus 1. So my possible rational zeros, my P over Q, since my Q is 1, it comes out as just all of my P's. So plus or minus 1, 2, 3, 4, 6, and 12, which means we have 1, 2, 3, 4, 5, 6. That means we have 12 different options. Alright, so let's pick one. Let's try 3. So write out my coefficients. 1, negative 2x squared, negative 11x, positive 12. That didn't give me a 0. So let's try a different one. Negative 3. So 1x cubed minus 2x squared minus 11x plus 12. And that one worked. Alright, so we have x, remember change the sign, so plus 3 times, our problem was x cubed, so our answer is x squared. So x squared minus 5x plus 4 equals 0. This one is factorable. Yay, we know how to do quadratic formula. So we have x plus 3 times, I'm going to go ahead and factor this out. So remember your first terms multiply to x squared, so x and x. Your last two terms have to multiply to 4, but they also have to add to 5. So 4 and 1 need negative, negative. And then we can just set them each equal to 0 and solve. So subtract the 3, add the 4, and add the 1. And so I have my 3 zeros there, and I should have got 3 because I started out with x cubed. Alright, then the linear factorization theorem to find polynomials with given zeros. Alright, so all it's saying is that if you have zeros, you can plug them in then as linear factors. Like we had that 0 of, what was our last one? A negative 3. And when we rewrote that as a factor, when we put it back in with x, we wrote it as x plus 3. So if we know what some zeros are, then we can write them as linear factors of our polynomial. So 4 says we're going to find a third degree polynomial function f of x with real coefficients. It has negative 3 and I as zeros, and is such that f of 1 equals 8. Alright. First thing is, guys, imaginary numbers come as conjugates. They come as complex pairs, okay? So if I have positive I as a 0, then automatically negative I is going to be 0 as well. Third degree polynomial here, this degree tells us how many zeros we should have total, right? It also tells me that my largest exponent is going to be x cubed. So the first thing you need to do is you need to figure out what your zeros are. So they told us that our zeros were negative 3 and I, and we said because positive I is there, so is negative I. So if I'd have had 2 plus I as a 0, then 2 minus I is also a 0, okay? They come in conjugate pairs. Alright, then what we're going to do is we're going to write these as factors. So the x minus 3 is going to give us negative 3, excuse me, is going to give us x plus 3. The positive I is going to give us x minus I, and the negative I will give us x plus I. Now what we're going to do is we're going to write it as a function, but I know that there could be a leading coefficient that we don't know what it is yet. So what we're going to do is we're going to write it as, let's say, f of x equals, and they call it a sub n. Doesn't really matter what you put there to hold that place, okay? But it's a sub n times our factors. Now that a sub n, I'm going to leave it till the end to deal with it. What I want to deal with first here is I need to multiply all of my factors together. So what we're going to do is, if they're even numbers, then you group them. Multiply these two, multiply these two, multiply these two. If there's odd numbers, you want to multiply 2 of them together first, and then multiply that answer times that third one. If you have imaginary numbers, you want to multiply them together first, and that's because that will make your I disappear. So we're going to do that. So let's bring down our a sub n times x plus 3. And we're going to do FOIL here, okay? So x times x times positive I, negative I times x, and negative I times positive I. Simplify that. So x squared, ix minus ix will cancel. So we got minus, remember I squared is the same thing as negative 1. So you get a sub n times x plus 3 times, this gives us x squared plus 1. Now we want to multiply those together. So we're going to do FOIL again. So x times x squared, x times 1, 3 times x squared, and 3 times 1. Now I don't have any like terms, but I am going to go ahead and put them in descending order of the exponents. So I end up with an a sub n times x cubed plus 3x squared plus x plus 3. Alright, now comes the point that we're going to find that leading coefficient. So remember, this is f of x equals. Now they also told us here that f of 1 equals 8. Remember, if f of 1 equals 8, it's normally f of x equals y, right? So we know that our x is going to be 1 and our y is going to be 8. So we're going to plug in 8 equals a sub n times, and for every x we're going to put 1. So this is just 1 cubed plus 3 times 1 squared plus 1 plus 3. And we're just going to solve for a sub n. So 8 equals a sub n times, let's give us 1, plus 1 squared is 1 times 3 is 3, plus 1 plus 3. So I'm going to have to borrow this other side again. So I have 8 equals a sub n times 1 plus 3 is 4, plus 1 is 5, plus 3 is 8. So this is 8 equals 8 times a sub n. So divide by that 8. And so 1 is equal to a sub n. Now once you get here, you're going to take this answer and you're going to go back to the polynomial form, which is right before you started plugging in the 8. Okay, so it's right here. And you're going to plug that a sub n there. So you have f of x equals a sub n is 1 times the x cubed plus 3x squared plus x plus 3. And then you're going to take whatever your a sub n is and you're going to distribute it through. So f of x equals x cubed plus 3x squared plus x plus 3. And that is our polynomial that has zeros. It's a third degree polynomial, so it's x cubed. It has real coefficients. It has -3 and I as zeros, and f of 1 will equal 8 when we plug it in. So there's our solution. Now, same thing as before, I'm going to do pencil problem number 4. So if you want to pause the video so you can try it on your own, and then start the video if you get stuck, or to check your work, you can. Alright, so we're after a fourth degree polynomial. Function has real coefficients. It has I and 3i as zeros, and f of -1 is equal to 20. Alright, so just like before, start out with your zeros. We know it's a fourth degree, so we should have 4 zeros total. They told me I, and they told me 3i. But remember, if I is a 0, then so is -i. And if 3i is a 0, then so is -3i. Remember, that only works on imaginary numbers, okay? If there are not imaginary numbers, then it is what it is. If it says that it had a 0 at 4, then only 4, not -4 unless they tell you. Only imaginary numbers can we say that the conjugate is a 0 as well. They have to come in complex pairs. Alright, so then our factors going to be x minus I, x plus I, x minus 3i, and x plus 3i. And now we can start writing it out. So f of x equals a sub n times x minus I, x plus I, x minus 3i, and x plus 3i. Now we do have 4 things here being multiplied besides the a sub n. And so remember, we want to multiply our complex conjugates together. So I want to multiply those 2, and I want to multiply those 2 together. So we can actually do this at the same time. So bring down my a sub n times, I'm going to do FOIL on this first one. So we get x squared plus ix minus ix minus I squared. And if you want to clean that one up first, then do that. I'm going to do that. So this gives me x squared. Those cancel. Minus, remember I squared is a negative 1. So a sub n times x squared plus 1. Then go work on your second ones there, okay? So when you do FOIL here, you get x squared. X times 3ix is 3, x times 3I is 3ix. Negative 3i times x is negative 3ix. And negative 3i times positive 3i is negative 9i squared. So clean this up. So we have x squared. 3ix minus 3ix cancels. So we get minus 9 times I squared. Remember, I squared is negative 1. So this gives us x squared. Negative 9 times negative 1 is plus 9. But now we still have to multiply these two together. So we have a sub n times x squared times x squared is x to the 4th. X squared times 9 is 9x squared. 1 times x squared is x squared. And 1 times 9 is 9. Then we just clean that one up. 10x squared. Alright, and so everything's multiplied together. So this is what our polynomial is looking like right now. Now where we stop and we go find what a sub n is. So we're going to go look. We know that f of negative 1 equals 20, which means x is negative 1 and y is 20. So 20 equals a sub n times, everywhere there's an x here, we're going to put negative 1. Then we're going to work this out. Negative 1 to the 4th. Remember, negative where you say an even exponent is positive, so I just get 1. Plus negative 1 squared, that's 1 times 10 is 10. Plus 9. So 20 is equal to a sub n times 20. Divide by that 20 so we can solve for a sub n. And just a coincidence that a sub n again is a 1, okay? Does not always come out like that. So remember, take that number and go back to right before you plugged in the 20, and you're going to plug it in for the a sub n and distribute it. So I'm going to come over to the side here. So we got f of x equals 1 times x to the 4th plus 10x squared plus 9. Distribute your a sub n. And so f of x is equal to x to the 4th plus 10x squared plus 9. And there's our polynomial. It has I and 3i as zeros, and that f of negative 1 is equal to 20. Okay, and then the last thing it tells us to do here, objective 5, is using Descartes' rule of signs. We don't use Descartes' rule of signs a whole lot, but every now and then it's useful, okay? But it says that we have to learn it, so we're going to go ahead and go over it. So it says determine the possible number of positive and negative real zeros. So this will tell us if there are any real zeros, how many of them are positive or how many of them are negative, okay? To find out the number of real zeros, you're looking for the number of changes in the signs for each term. So like it goes from positive to negative or negative to a positive. But if you want to know for the positive real zeros, you have to look at when you plug in positive x into the function. And if you want the number of negative real zeros, you have to look at the sign changes when you plug in the negative x into the function. Alright, so for your positive real zeros, turn on my pen here. So for the positive real zeros, we just look at what's given. Okay, because they're always going to give us f of x. So we have f of x equals x to the 4th minus 14x cubed plus 71x squared minus 154x plus 120. And so let's count our number of sign changes. We started out with a positive x to the fourth, and it went to a negative 14x squared, or x cubed, excuse me. So that changed. It was a positive, then it's a negative. Now we go from a negative 14x cubed to a positive 71x squared. It changed there again, from a negative to a positive. Then we have a positive 71x squared to a negative 154x. It changed from positive to negative. And then we have a negative 154x to a positive 120. It changed again. So we have 1, 2, 3, we have 4 sign changes. So the number of positive real zeros possible is there could be 4, or you subtract it by an even number, which means you subtract it by 2 until you either get to the number 1 or the number 0. So 4 minus 2 is 2, or 2 minus 2 is 0. So there could be 4, 2, or 0 positive real zeros. Now to find the number of negative real zeros is that you're going to do the same exact thing, but you're going to find it using f of negative x. So the negative real zeros we're going to go find f of negative x. And so we have to do a little work here before we can do the other. So we have negative x to the fourth minus 14 times negative x cubed plus 71 times negative x squared minus 154 times negative x plus 120. So simplify this. Remember, negative raised in even is positive. Negative raised in odd is negative. So negative x to the fourth is just x to the fourth. Negative x cubed is negative x cubed times the negative 14 makes it positive 14x cubed. Negative x squared is positive x squared times 71 is positive 71x squared. Negative 54 times negative x is positive 154x, and then plus the 120. So when I look at this now that it's simplified, we're going to look for the number of sign changes. We went from positive to positive, no sign change. Positive to positive, no sign change. Positive to positive, no sign change. Positive to positive, no sign changes. So there were no sign changes, which means there are no negative real zeros. So what does that mean? Well, none of them are going to be negative. So could be we have a positive. We could have 2 positive. We could have 4 positive. Or if we don't have any positive ones either, that means they're all imaginary. Okay, didn't tell us to find them. It's just a clue to help us. So like if we were looking at what we did earlier when we were solving them, that kind of clues us in. If I know there are no negative real zeros, when I'm looking at my P over Q's, I'm not going to pick any negative ones. They can't work. Okay? Now those are rational numbers, but remember all rational numbers are real. So then I would know on them, you know what, let me try some positive numbers first. I would try my positive ones. Alright, so just like before, I'm going to do pencil problem number 5. If you would like to pause it, you can. Alright, so to find your positive real zeros, remember, look at the sign changes of when you plug in f of positive x, okay? Positive to a positive, positive to a positive, positive to a positive. There are no sign changes, which means there are no positive real zeros. So if I was going to pick from my P over Q's, I'm not going to choose any positive ones, okay? Now I'm going to go find f of negative x so I can see about my negative real zeros. Alright, so I'm plugging in negative x for all of my x's. I'm going to simplify that. So negative x raised to the third is negative x cubed. Negative x raised to the second is positive x squared times positive 2 is 2x squared. 5 times negative x is negative 5x, and then plus 4. Alright, now let's count a number of sign changes here. We go from a negative x cubed to a positive 2x squared. That's a sign change. Excuse me. Positive 2x squared to negative 5x. That's also a sign change. Negative 5x to positive 4. That's a sign change. So I can see that there are 3 sign changes, which means there are 3 or 1 negative real zeros. Remember, you always subtract 2 until you either get to a 0 or a 1. You won't ever have any that's negative, so you can stop there. So this tells me that I am guaranteed that at least one of my real zeros is going to be negative, okay? So if I'm looking at my P's over Q's, I'm going to start picking negative numbers for this problem. Alright guys, so that there is the end of 3.4 where we talked about the zeros of different polynomial functions.